solve the system of linear equations below. We're going to use the method of elimination to solve for x and y this time around. Now we can do that because I see easily we have a coefficient of x in the second equation that is a factor of the coefficient of x in this first equation. And so what I'm going to do is I'm going to multiply this entire second equation by 2 so that I can eliminate the variable x when I add these two equations together later on. So if I multiply every single term on both sides of this equation by 2, that gives me a new equation that has the same value as this old one. 2 times negative 8x is negative 16x. 2 times negative 6y is negative 12y equals 6 times 2 is 12. Okay, now I can add this new version of my second equation to the first equation right over here. So 10 plus 12 is 22. Negative 10y minus 12y is negative 22y, and 16x minus 16x cancels out. That is simply 0. Now I can solve for y. Y equals, if I divide both sides by negative 22, y equals negative 1, and I have my value for y. Let me plug this back into my first equation to solve for x. 16x minus 10 times my new value for y is negative 1 equals 10. 16x plus 10 equals 10. 16x, I subtract 10 from both sides, 16x equals 0. And if I divide both sides by 16 to isolate the x, I get x equals 0. So I just used elimination to combine both equations and find that y equals negative 1 when both of these equations are equal to each other, and x equals 0. That is my solution to the system of linear equations.